Hey everyone, and welcome to Dr. Abu Art 10 Academy channel. Today we are going to discuss part 10, which is the last part in the PDF file given by the University of Debrecen for sets and probability in the biostatistics topic. In this video, I'm going to teach you the two exercises which appended to this PDF file. This exercise about the probability is two-dimension exercise. What does it mean, two-dimension exercise? It means it has x dimension and y dimension. So I have some data listed down, and also I have some data which put in the x-axis. So on the x-axis I have the quality of the high school. So I have some high schools, and this is the quality of the high school. So we have low quality high school, secondary school. Okay, I have medium quality secondary school or high school. I have high quality high school. Okay, and on y-axis I have the test results of this school. So I have poor results, I have satisfactory results, and I have excellent results. Okay, so some of these low quality schools might have some excellent students. So it doesn't mean that if you have low quality school, high school, all the students will score low. So in this low quality schools, some of the students also are still scoring high scores, and some of them are scoring satisfactory scores. And also the same thing, I have some high quality schools but still have some students who are scoring very poor results, okay, in the test. So it is good to understand how this table is organized so you can easily understand the probability and answer the problem. Coming to the first question here, what is the probability that a randomly selected student? So in all the questions from 1 to 5, we are talking about one student selected randomly. So what is the probability of, and you have 5 criteria, so 5 questions. So every question will have separate answer and separate scenario. Question number 1, what is the probability that the selected student achieved an excellent result? He didn't identify here or specify whether this student is coming from high quality school or from low quality school or medium quality school. Just he's talking about the excellent result. Excellent is on y-axis, so I have poor result, satisfactory result, and the excellent results. So regardless of the school which you have, so regardless of the school, so how many students I have who scored excellent grades? The students who score excellent grades are these. So I have 25 students scored excellent grade in the low quality school, 65 of the students scored excellent grade also in the medium school, and 300 students scored excellent grade in the high school. So the total or the sum of them would be 25 plus 65, which is 90, plus 300 equals 300. So here I have already the total here. So this column is the total, and this column is the total. This is the total of the horizontal rows. This column includes the total for them, and this row includes the total of the above. Okay, so coming back to our question, the students achieved an excellent result. The total number of students, because he did not specify students achieved excellent and he came from low quality or medium quality or high quality, he said in general achieved excellent result. How many students in general overall achieved excellent result? 390 in total. 390 students. Okay, out of how many students? The overall students which I have is 1000. So the total number of students in the low school, in the medium school or high school is 1000. If you want to take them grade wise, I have 220 scored poor, 390 satisfactory, 390 excellent, so the total also will be 1000. So 1000, this is the total number of the students. Okay, so what is the probability of the students scored excellent result? It will be the total. We said what is the criteria which we are looking for? We are looking for excellent result. how many scored excellent result. Probability, okay, in this case would be equal, I have an event, so the probability would be what is the required criteria, the favorable criteria divided the total. Okay, so what is my favorable criteria in this case? Excellent. So excellent students who score excellent, they are 390. The total is 1000, so the answer will be 390 divided 1000. This is the answer. Okay, so the probability of achieving excellent result equals the desired, what is the desired criteria? The favorable criteria, excellent result. Overall, he did not specify excellent with some other condition. So I'll take the excellent, the total of the excellent is 390 divided the overall total is 1000. The second question is come from a high quality school, that the selected students comes from a high quality school without specifying any other criteria, only just coming from a high quality school. How many students come from high quality school? This is high quality school. The total number is 500. Total number of students is 1000, so it will be 500. My desired criteria 500 divided the overall 1000. Okay, this is the answer. Okay, the third question is got a poor test result and it came from high quality school. So here we have two conditions, but it's not a given case. So he has got a poor test result and it came from high quality school. So it is the intersection between these two. So where is the poor test result? Here the poor test results. Okay, it's better to make it in to highlight it. Poor test results. Okay, and came from a high quality school. This is the high quality school. So they are intersecting in this. So those are the students who score poor grades, poor test results, and at the same time they came from a high school. Their number is 55, and the total number of the students is 1000. Question number 4 is a little tricky because it is a given case, but it is not tricky for us because we're already well trained on such type of questions. So got a poor test result. So here the question again, the probability that the selected students will get poor test result given she came from high school. So I have two conditions here. This is a given case. If you recall, when we explained the given case, what we have said if I have probability of A given B, it means probability of A intersect B, the same thing, but just I am changing or replacing the given line by intersect. So probability of A intersect B divided the second one, the probability of the second one, divided the probability of B. So this one will go up, but just I changed the given to intersect, and this one will go down, probability of B. Also the other way, which we are using in Debrecen, so probability, instead of writing A intersect B, we can use AB, because we use now to use this way as per the Debrecen slides. So instead of saying A intersect B, we can use AB. This is the notation which they are using. Okay, and divided the probability B again. So this or this, both are the same. Okay, so let us apply this concept now on the problem which we have. So probability of A given B. Here I got the student got the probability of a student got poor result. So the probability of A. So A in this case, the student got poor result. So he's asking for the probability of what? Of A. Probability of poor result. Okay, I just call it poor. Okay, given that she came from high quality school. So this is the given, high quality. So what it will be equaling? So probability of poor score, given that they came from high quality school, it would be probability of this one intersect this one. Probability of poor intersect high quality. Divided the last one, probability of high quality. So here, what is the intersection of probability of poor intersect high quality? This is the poor here, and this high quality, the same problem which we have taken in question number 3. Okay, poor and high quality. So this is the poor and high quality, the intersection between poor and the high quality. It's 55. So the answer for this one would be, let us write it here down, equals, the denominator will be 55. Divided the probability of high quality. What is the probability of high quality? High quality, this high quality, this is the total number. Okay, it is 500. Okay, so I have the intersection of poor with high quality divided the probability of having high quality. Okay, the last one. So it will be 55 divided 500. Okay, and this is the answer. Okay, this is the answer. So we can recognize the difference between 3 and 4. 3, it was a straightforward intersection, okay, between the poor result came from high quality, poor result came from high quality. So it is 55. Okay, poor quality came from high result, 55, dividing the overall, the total, because it is not a given case, it is normal probability. Normal probability, the desired criteria or the favorable criteria divided the total. This is the favorable criteria which I'm looking for. Poor with high, poor result with high quality, divided the total, which is 1000. But in the second case, it is a given question. Given, I have to apply the formula. So I have to say probability of A given B equal A intersect B or AB. Okay, divided probability of B, not the overall, not the total. Okay, so it will be the probability of poor intersect high quality, the same one, 55, but in the denominator we'll have the probability of the high quality only, not the total number. Okay, this is the formula, probability of the high quality, which will be 500. So here it will be 55 divided 500. So question number 5, what is the probability? Again, every time we have to read it. What is the probability the selected students achieved an excellent result? Or, so we know that this one or this one means whatever here and there or together. If I said, okay, if you have green or red, how many you have? So you count the green and count the red. Okay, you have the balls which has green color or red color, how much they are, you count both green and red. But if I said the balls which has green and red, so you have to count only the one which has the two colors inside them. Okay, so here or means we have to add, it is union, whether it has green color or red color, we have to put them together in one bowl and count all of them, because it is or this. So he gave us the choice, so we have to put all together, either this one or both of them. At the end of the day, if it has this color or this color, it has to be counted. Okay, so or means union. But if it has green and red, so we have to count only the poles which has green and red, but the one which has green color only we should not count, yellow color only we should not count. The same thing will applicable here also. The students achieved excellent results or came from high school. You remember we said this is union problem, A union B. So if I have A union B, this means all the, for example, this is green color, so all the green color, and this is yellow color or the yellow color, so I have to put all of them together. Sorry, it is a sorry, I'm sorry, this is a union problem. So A union B means if it is green, I have to count all the green, and if it is yellow, I have to count all the yellow and add them together, because this is union. It is like a bowl, and I'm putting everything inside the bowl. Okay, everything I put here and everything I put here, and then count all of them together. Okay, so the union means both of them, this one or the other one. So or means union. Okay, so if you remember the question, the formula which we have for the union, general formula, we said initially, we said that okay, A, if I have A union B, the probability of them equals the probability of A plus probability of B. You remember we said that? Yes, yes. But we said this subject to, they are disjointing. There is no overlapping between. So we say that this would be applicable if they are disjointing. I have the two sets, set A and set B, and they are disjointing. So it would be the probability of this one, B plus probability of A, or probability of A plus probability of B. But if there is any intersection or overlap between them, we cannot use probability of A plus probability of B. We have to use the general formula, which is probability of A plus first one plus probability of B minus the probability of the intersection between them, because we said this part would be counted twice now. If we did not consider this part, so this overlapping would be counted twice. It will be counted with A, and it will be counted also with B, because it is here and here. So we have to subtract one of them. Okay, so our question is, what is the probability the selected students achieve excellent or means union came from high quality school? So I write A union B. In this case, because it is not given case, order matters. A given B different than B given A, but in the union or intersection, it doesn't matter. So A union B, it's same as B union A. So the probability of A union B equals probability of A. So we'll take the first one A, achieve excellent. So we'll call this one A. Okay, so let us get this one. Okay, so we'll call this one A, excellent result A, high quality school B. So the probability of A, excellent result. What is the probability of excellent result? Excellent result, here we have already got it. Extra result 390 divided total 1000. So 390 divided 1000. This is the probability of excellent results. Okay, because excellent result, this is the one, and the total 1000. So probability of B is high quality school. So what is the total of high quality school? Only high quality. So here I'm talking only about high quality. So I have to focus only on the total of the high quality, regardless of they are poor, satisfactory, excellent. I'm talking about only high quality school. So I have to focus only on high quality school. So the total of high quality is 500, and the total number of students is 1000. So plus 500 divided 1000 minus A intersect B, high quality intersect excellent. Okay, so excellent and this high quality, so 300 divided the total also, which is 1000. So I'm dealing with everyone separately. Excellent, as I'll consider that I don't have any other thing except excellent. So when I come to think about each individual one, I have to think like this. I'm thinking about excellent, so I have to consider that I don't have anything here, like achieved an excellent result. What is excellent result means? Okay, so what's excellent result means? Excellent result means 390, go here, 390 divided the total. As a separate problem, 390 divided the total 1000. So I put it here. This is the probability of A, excellent. When I come to the probability of B, which is high quality, so I ignore everything and consider only high quality. So I consider he achieved high quality school. So when I look at high quality school, what is high quality? High quality school. This is the high quality. Come here. So 500 divided 1000. As I don't have any other thing in the problem except this one, probability B. Probability B, probability of high quality, 500 divided the total, and ignore any other thing. So the second probability will be 500 divided 1000, which is B, the high quality. Then the intersection, I look at the intersection like I don't have any other thing except the intersection. The same way, the intersection, so I have high quality and I have excellent, so 300 divided 1000 minus 300 divided 1000. So the total will be 390 plus 500 equal 890. 890 minus 300 equals 590, and the denominator would be the same, 1000. So my answer would be 590 divided 1000. I hope that this one is clear. In this exercise, also it is a two-dimensional problem. So I have also x and y. So I have two variables, variable on this dimension and variable in this dimension. So also they are intersecting, variables are intersecting in the same way with the other problem, the previous exercise which we have taken. Okay, so let us read the question here. The probability that a randomly selected person from a population shows symptom of a disease. So the first one shows a symptom. So how he feel, he has fever, he has pain, he has some symptom. It is not the disease itself, just the symptom of the disease. Okay, so the shows a symptom of the disease, but he has a symptom, but maybe many other people has the symptom but they are not sick, they don't have the disease, but they shows the same symptoms, because some symptoms are common between more than one disease. So maybe many people will show the symptom but they don't have this disease, maybe they have some other disease, maybe they are not sick at all. The same thing that we might end up with some people, some students or some people, they have the diseases but still they do not show the symptom. So they have a problem, internal problem, but the symptom, the fever is still not started, the change in the eye color is not yet started, the pain is still not started. So maybe they have the disease but still did not show the symptom. On the other hand, maybe some people are having the symptom but they don't have the disease. Maybe they have, maybe they don't have. So this is what we are going to see in this example or this exercise. So the exercise said the probability that a randomly selected person from a population shows a symptom of a disease is 0.2, and the probability, so here this is the first probability of symptom 0.2, and the probability that the same randomly selected person has the disease itself is 0.23. So he has the probability of showing the symptom 0.2. As we know that the total probability of any events equals to 1. So if I said, okay, students either attend the school or they are absent. If I said that 30% absent, it means 70% attended. Okay, if I said I have students of wearing in the class two colors, white or blue. If I said that, okay, the students wearing blue color are 50%, so the other 50% will be white color. So they are complementary. At the end of the day, the total probability should be 1. If one of them 0.2, the other one will be 0.8. One of them 0.9, the other one will be 0.1. 0.5, the other one will be 0.5. The sum of them should be adds up to 1. If I have 3, one of them 0.2, the other one 0.5, so the total is 0.7. The third one will be 0.3. So all of them, the sum should be adding up to 1. Okay, so if I said I have students who have the symptoms 0.2, so what is the probability of the students who don't have the symptom? 0.8. Symptom is different than the disease. Disease is something and the symptom is something else. Okay? So I said X person attended school with a pencil. The other one did not attend with a pencil. So he came without pencil. So either with or without. Okay? The same way here. Some people has the symptom and some other people doesn't have the symptom. So if I said I have 0.2 have the symptom, so 0.8 doesn't have the symptom. If I said 0.23 has the disease, so the complementary of this one, to complete one, doesn't have. So it will be 76. 76 doesn't have, sorry, 77. 77 doesn't have the symptom. Okay? Okay, so the person selected from the population shows symptom of disease 0.2, and the probability that randomly selected person has the disease itself, okay, is 0.23. The probability that the person shows symptom and has the disease, this is the intersection. Symptom, for example, symptom and disease, or the other way around, okay, or symptom and disease, okay. The intersection between them, it is 0.18. Okay, this is what we are going to discuss in detail now. Okay, so the probability that the person shows symptom and has a disease 0.18. This is one of the intersections between them. The person is selected who doesn't have the symptom. The person is selected doesn't have the symptom. What is the probability that the person has the disease? So he mentioned here clearly that the person is selected who doesn't have symptom. So it is like given, kind of given. He told me don't think about it. He doesn't have. It is given. It's already confirmed. I can assure you, confirm that the person who doesn't have the symptom. So he came to the students or the persons and asked them, do you have the symptom? Do you have? So no one of them has the symptom, or he checked the temperature, they don't have the symptoms, so he picked one of them. So that's why he confirmed here the person selected who doesn't have any symptom, doesn't have the symptom. Okay, so this is given that he doesn't have. What is the probability of the person has the disease? So here the question will be in this form: probability of what? Probability of person has the disease. The person has the disease. Okay, but given that he doesn't have the symptom, so symptom negative. If we assume that has the disease is disease positive, so symptom he doesn't have, instead of writing doesn't, so just to write doesn't have symptom. Okay, so we'll adjust S negative. If we write S positive, symptom present. Here symptom doesn't present, he doesn't have. Disease positive, so disease, he has the disease. Disease negative, he doesn't have the disease. So the question will be probability of the person, the probability has the disease. Disease positive, given what? That he doesn't have symptom. Symptom negative. Okay, let us, as shown in this way of solving, let us answer it here together. Okay, so I have the table. I can draw two-dimension table here, one of them which will show the symptom and the other one will show the disease. Okay, so I have two, for symptoms I have two scenarios: either symptom positive, he has the symptom, or symptom negative, he doesn't have the symptom. For the disease, the same thing, he has disease or he doesn't have the disease. Okay, I could add one more column here and one more line here, or I can write it under the table as the way they did here. Okay, so if you want to draw it 3 by 3 table, you can draw it 2 by 2 table, or you can add one more column for the total. Usually we are adding one more column, so if it is 3 criteria, I have to draw a table of 4 by 4. If I have 2, I have to draw 3 by 3, adding one more column and one more row. But also you can draw it 2 by 2 or 3 by 3, exactly the same number, but adding the total here outside. Okay, so if I want to draw it 3 by 3, I have to do it in this way. 3 by 3, 1 2 3, 1 2 3. Okay, and here I'll have, this is S dimension or D, and this is S, sorry, this is S. This is, so here I have D positive, D negative, and this is the total. I have also here S positive and S negative, and this is the total. Okay. So he mentioned here in the question that the person randomly selected from the population shows symptom disease is 0.2. So the probability of the person having symptom, the total is 0.2. Okay, so this is the total probability, or the total probability of the person who has symptom. So what is the symptom here? The person has symptom is here, is capital, the person has symptom. So the total of this number of these people or these persons equals 0.2. This is the total number of the people who are having symptoms, 0.2. And he said the probability that randomly selected, because this randomly selected, he didn't say symptom was a disease or symptom was no disease. He said no, only symptom. So he's talking about the symptom, so he's talking about the total of the symptom. Okay, so the person when he selected who has the symptom is 0.2, and he said the probability that randomly selected person has the disease is 0.23. So what is the disease? This is the disease. This one doesn't have, this one has the disease. Okay, so what is the probability? Is 0.23. Okay, we say that, okay, if the probability of having the symptom is 0.2, so the probability if we doesn't have the symptom is 0.8, right? 0.8. The possibility that, or the probability that they will have the disease, 0.23. So the probability that he doesn't have the disease, it will be the complementary, which is will be 0.77. Okay, 0.77. So if we add up these two together, they will give us 1. If we add these two, it will give us 1. So now we are right. Okay, so in order, but we doesn't know the combination here, the intersection between the one who has symptom and disease, and symptom and doesn't have the disease, and so on. So he has to give us at least one of them. So here he has really give us here one, the probability that the person who shows symptoms and has the disease, 0.18. Symptom and disease. So here, okay, it is 0.18. So here from this one, the total is 0.23 and this one is 0.8. So the one who has the disease but doesn't show the symptom, the 0.23 minus 0.18, which is 0.05. Okay, because 0.18 plus 0.05 equals 0.23. So I want to get this this one, I have to subtract 0.23 minus 0.18. Okay, because I have the intersection disease with symptom and the total. The total of these two are 0.23. So in order to get this one, I have to subtract 0.3 minus 0.18. So what about the rest? Here I don't have anything. So how I can find them? It is easy. I have here for the people who has the symptom 0.18 and the total is 0.2. 0.2 means also 0.20. Okay, so here's 0.02. 0.20 minus 0.18 equals 0.02. Okay, so now I got this one 0.02. Okay, it's like the crossword. Okay, 0.02, and here we have 0.77, so it will be 0.77 minus 0.2, 0.75. So I have all of them. So coming to our question here, what we were looking for, the probability. He said the person who doesn't have symptom, or doesn't have the probability of the person who has the disease. So the probability, the first thing what we are looking for, we're looking for the probability of what? Probability of person has the disease. So probability of the disease positive. But given that the person doesn't have symptom, it's negative. So probability of D positive given as negative equals probability of D positive intersect is negative, okay, divided probability of the last one. So just I'm converting this one into intersection, okay, and divided probability of S negative, which is this one, okay. So probability of D positive intersect S negative, D positive intersect S negative, which is 0, 0.05, this one, okay, 0.05, divided the probability of S negative. S negative only means the total, 0.8, which will give us 0.00625. If we want to write it as a percentage, we have to multiply it by 100%, so it will be 6.25%. This was the last exercise in the sets and the probability, and I hope it's clear, and I hope that you fully digest the sets and probability, and thank you very much for watching these videos. Thank you very much.